Okay, so now we're going to take a, well, actually that doesn't matter. We're going to take a point that's not in a circle, and then we're going to make a circle, we're going to make another circle. Okay, so here we have circle B and point A, which is outside of it. So now the question is, how do we construct the tangent lines from A to the circle? So the key to this is to remember, let's remember that the tangent lines have a special property. Now the easy thing to do right here would be to go in here and use the construction menu and just say, where are the tangents? So let's do that. Let's find the tangents, and there they are. So what is the property that we remember? Let's find that intersection point, and let's find that intersection point here between the tangent line and the circle. So here we go, tangent line and the circle. So we have those points, and let's remember that if we draw the segments, right, and measure those angles, that we have a very special property, right? What was that? Let's try that again. Measure angle BDA and measure angle AEB. The property is that those tangent lines are always perpendicular to the radius at the point of tangency. So that's important to remember. Okay? So what we're really looking to do is we're looking to create a right triangle with AB as the hypotenuse. With AB as the hypotenuse. Now I want you to remember something about that. Remember that when we constructed, let's look at this, watch. I'm going to scroll away from this real quick for a second. Remember if we had a circle here, right? And then if we constructed, let's say, the line that goes through those points, and now we're going to get that intersection point. So let's make the diameter. Here I have this diameter. Okay? So now, you might remember that we said there's always going to be a right triangle that exists with this as the hypotenuse. Okay, with this as the hypotenuse. So let's see how we could do that real quick. Let's try and remember this. If I made a parallel line, say parallel to the x-axis that went through H, and another parallel line parallel to the y-axis that went through G, okay, and then I found the intersection point, it would always be on this circle. What happens if I adjusted the circle? It doesn't matter because G and H are always a diameter, and so we see that I represents all of the points that can exist to make a right triangle with this as the diameter. So this is the important thing to remember. A circle, right, or a semicircle represents all of the points that can be made, where a right triangle can be made with the segment as the hypotenuse of that right triangle. So we go back up here. We know that we want a right angle for this triangle, so we need to create this circle. So let's watch what I'm talking about. See if you can see what I'm talking about. From A to B, we now have two right triangles, right? We have a triangle here and we have a triangle there, which means that I need to construct this circle. And if you think about it, now I'm doing this kind of backwards for a minute. But let's find the midpoint of that segment. Oops, that wasn't what I wanted to do. Let's try that again. We draw the segment, and then let's find the midpoint of that segment. And now you should see that if I were to draw a circle from the midpoint of the segment, it's going to intersect this other circle at exactly the point of tangency every single time. And that's because this is one of the points that forms a right triangle for that hypotenuse that is also on this circle. Right? Alright, let's try this again. So that's the information you need. Let's see if we can walk through it a little bit differently. In fact, let me start over again. And let's just say, with that background knowledge there, let's try actually just thinking through some logic. So I have a circle again, okay? I'm going to take away point A. And or B rather, and I'm going to make a point that's just, out there somewhere, C. So my first job is saying, hey, I know that I want this segment here. My second job is, can I find the midpoint of that segment? Sure, if you're doing this by hand, you could construct a circle and another circle, right? And then all you would do is just make sure those two circles had the same, let me show you exactly what I'm talking about. Let's say I make a circle here, center A, and it goes out a little further, right? And then let's say I copied circle A, sorry. Let's undo that. Okay, let's do it again. Circle A, and then let's say I think I can copy, Control C, maybe edit and paste another circle. Just place it at center C, so it's the same circle, right? And then I can intersect those circles here. So then I can construct the line or the segment that goes through these two guys. So this is the technique that we use that you might remember from Geometry A to find the midpoint of a line. Okay, now we wanted to draw this tangent line from point C to that circle. And remember that we knew that it was going to be a right triangle, so we're going to draw a circle, and wherever it intersects will be both the circle that has these inscribed in it, and this at a center, right? And it will also be the point that's on this circle. Okay, so let's go ahead and draw that. Okay, find our intersection point there and there. Okay, and then we can draw our lines. Well, let's draw a ray. Here we go, our ray from C through H. There's one tangent, and from C through I, there's the other tangent. Okay, that's the way you do it by hand. You would draw one circle with this being the center, goes past the midpoint, then using the same radius, draw another circle, and then we would find that line that's the perpendicular bisector, and there's the midpoint. Use the midpoint to construct another circle, and then we would know. What do we know? We know that this triangle is going to be a right triangle. We know it, and we can measure it to prove it. 90 degrees. Okay? Shall I make the list of steps here? I think so, just to kind of try and help you out. What are you going to have to do? Well, okay, first we construct the segment from the center of the circle to the point outside the circle. Then we find the midpoint of that segment. Then we draw a circle with center at that midpoint and radius at the end points of the segment. Then we find the intersection point of the two circles. Then we draw a ray or a line from the point outside the circle to the intersection point on of the circles. Okay, let me see if I can do that one more time, just following those steps here and doing it real simple. I'll use the midpoint tool this time. I won't use the old technique for finding the midpoint. I'll just use the midpoint tool, which is very acceptable here. Here we go. I've got a circle and I've got a point outside the circle. I'll get rid of K here. So I'm just talking about circle J and point L. Okay? Now I construct my segment between J and L. That's my first step here, is to construct the segment from J to L. Then I find the midpoint, so I can use the midpoint tool for that. There's my midpoint. Oh, it just happens to be on the circle. I don't like that because it could get confusing. So there we go. Now we draw a circle with the center at that midpoint, right? And the radius at the end point. So I use my circle tool and I go from the midpoint to the radius. Then I find the intersection point of these two circles. So I go here, intersection point of these two circles. They intersect here and here. And then I can draw my line or my ray. I'm going to draw rays from the outside point through the intersection points, and there I have it. And now I can see that even if I adjust or change the outside point, as long as I've used the right technique, it will always work, even if I change, the circle itself or the point. Okay, that is the technique.